Okay, everybody, so we're doing the basics of linear regression and some of the very cool plotting that is possible here in our studio. So I'm going to walk you through all of the code and such. And so the first thing that I want to do is I actually want to sort of read the football data. And so I'm going to import that in. Okay, so over here I actually have my code, right? And so I have a CSV file that has the top 25 um, for 2018 college football scores and some data and stuff. And so basically what I'm going to do is I'm going to call that football data, and I'm going to read that CSV file. Copy, and we're going to put it over here. So this, I'm just calling it football data. It's reading the file. I hit enter. Now that football data is over here, so you can see rank, team, conference, yards, passing yards, and such, right? So that is a data set that is now input into the system, right? So now what we want to do is we want to actually start building our linear regression, right? So what I'm going to do is I'm going to create rushing, okay, a rushing from the football data, and I'm going to use the rushing yards per game, right? So let's copy that and paste it in. Now, the football data is above. The dollar sign tells us what we're going to call, and we're going to call the rushing yards per game, right? So here in the football data, there is a rushing yards per game, and so that is what I'm calling up. Now, it's actually pretty easy to call it up in our studio. Once I start doing the data, right, and then I do the dollar sign, all of the possible variables, all of the possible columns come up, and so I'm just going to do the rushing yards per game. I'm actually going to do the same thing with points, and so I am going to do the football data, and then I'm going to do the dollar sign, and then not total points, but points per game to keep rushing yard and points per game the same, right? So now I am actually ready to do the linear regression, right? I'm gonna call it rushing model, and I'm gonna do the linear regression. So I'm gonna call it rushing model. You can see I already tested it out, right? This stuff is coming up. LM for linear model. We're gonna do points as our y, right? And then I'm going to do the tilde, and then rushing is going to be our predictor, our x variable right here. So now once I do that, I can do the summary data of our rushing model, and we want to definitely hit the model, okay, and put that in. So the linear model is points being predicted by rushing. Here are my residuals for the histogram, which we're going to look at in a minute. Here is my estimate for the intercept. Here is my estimate for the slope for rushing. This would be the change in points due to rushing yards. Here's my standard error. It is a t distribution, so I get a t test statistic that's here, and we can see that this is not a significant predictor at the 10% or 5% level of significance. All right. So now, which is pretty important, right? So rushing is not a significant predictor of points. Now, a football field is 100 yards, and so if you actually took this and you multiplied it by 100, you'd have about 3 points, 2.5, 3 points, and so that's about half of a touchdown. So it looks like it would take about 200 yards rushing. And so maybe rushing yards is not a great predictor of score. And that's what that's saying. Now, the multiple r squared here is at 0.10. So about 10% of points are explained by rushing yards. That's what that means right there. And I would use the multiple r squared and not the adjusted, because we only have one predictor, right? The rushing. And so I don't actually have multiple r's. And so this one is perfectly fine. If I did have multiple predictors, I would want to use the adjusted r squared value, but I'm not going to do that here. Now, one last thing, because we only have one predictor, even though this is a t-distribution, I get 0.118, okay? Here I have an f statistic. This is for my model. How well does this model do? And that's an f distribution, but the p-value is the same because I only had one predictor, right? When I have multiple predictors, then that f statistic is going to generate a p-value for the overall model. So here, in a single linear regression, this is doing that. Now, maybe we want to look at the ANOVA table. That's something that we might want to look at for our rushing model. And that will give us the same f-stat and p-value. But now I have my sum of squared for rushing, the sum of squared for the residuals. I have the mean squared value for both of them as well, right? So that's the ANOVA. Okay, so now we're going to go back. So that's just some of the, like, how do I get the model? How do I look at the summary statistics for the model? Now we want to be able to assess the model. And now with that, there is residuals. Okay, so I have a thing called residuals. Now it turns out that there is a residuals in the model, the linear model. If we look, let's see, prediction, right, there's a list of 12. My mouse just died. Okay, so I'm going to do residuals. I come over here. There's my rushing model. There are residuals stored in here, and I can call those with this function. So what I'm going to do is, with my rushing model, I'm going to save the residuals in a residuals variable so that I can take the histogram of those residuals. Now, I want to do this one, right, because that's the actual data set. That's why it's in purple. And here is my histogram of the residuals. And you can see it's centered at 0. It's looks like it's a little skewed to the right. And so maybe it's not a great fit for a linear model. All right. So what else might we want to look at? Well, you can plot, right, the rushing model. And what we want to do is we're going to plot number 2. Number 2 is the QQ plot. And I can see the QQ plot here. Value 22 is getting sort of far away. This value right here, this is sort of far away. It's not really snaking like I would like it to. And I don't have a correlation coefficient. So maybe what I really want to do is I want to assess the normality of the residuals to make sure that they're perfectly normal. And the final way that we would do that is with the Shapiro test. And if I do the Shapiro test on the residuals, right, I see that I do not have a statistically significant result. It is 0.2-ish, right, rounded. And so it's toward the edge of normal, but we're going to say that this is normally looking data. The plot is, the histogram of the residual is centered at 0. And it's not terrible. It's not great. It definitely looks right skewed. I'm not going to lie. But it is centered at 0, and it is unimodal. The QQ plot doesn't look great, but it doesn't look terrible. And then I do have normality with the Shapiro test. So I'm going to say it's probably okay. It's probably okay. All right, so now we've assessed that. Now I actually want to look at, like, how do I plot some of those really cool plots, right? So the first thing that I need is my ggplot2. The ggplot2 is a really powerful package. I've seen it referenced in a bunch of books that I've been using as a reference material. And so under tools in RStudio, you have the ability to install packages, and you just start typing in ggplot, and ggplot2 is one of those, and I can install it. Now, I don't need to install it because I have already installed it, so I'm going to click on cancel. Now, once you have installed it, don't forget you need to call that library and the library is the ggplot2. And so we're going to make sure that we can access that. Now, I am going to copy and paste this one, and then I'm just going to walk through what I did. All right, so we're going to go ahead and copy that. I'm going to go over here, and we're going to paste. Okay, and so let's make sure. So there's a plus sign here and a plus sign here. I think that's okay. But here's what I did, right? We're going to plot the football data. This sets up the grid. The AES sets up the grid. And I want it to set up the grid for X is going to be my rushing and Y is going to be my points. And I've already defined the rushing and the points, and they are part of the football data. Okay? And now the geo point, this is the scatter plot. So I'm going to create the scatter plot, and I'm going to make it size 3. And the alpha is the amount of transparency, and I'm going to make it 0.5. I feel like this is a pretty nice scatter plot, okay? And then the last thing that I'm going to do is I'm going to use the geo smooth, and this is going to add the linear model for the points and the rushing, and I want that to be red. And by putting in the fill, I'm actually going to put the confidence interval around my linear regression is going to be the fill, and I'm going to put that in pink. So when I hit enter, oh, see, it doesn't like it because I think there's a couple of extra. Now let's see if it likes that. There we go. Okay, so there were a couple of extra plus signs that it didn't like in there from the copy paste. Okay, so now you can see. So here's my points. All right, they're fairly dark. They're maybe a little large. Okay, but here's my red line. Here's my linear regression. Here's my confidence interval for that linear regression. It ends up being an hour shape because the rushing, the slope is about 0.4, but it has a standard error of about 2.5, which means that that slope could be as small as 0. In fact, you can see 0 would be right here. It could be as low as 0, and it could be as high as 5.9. It could be as high as a slope of 0.9, and that would be up here. So if I take this line and I pull it down to here so that the slope is 0, that means this tail end has to come up. All right. And then if I pull this up here, then you can see the straight line goes down over here. And you're like, well, why is it pivoting around here? Well, it turns out that the average yards rushing and the average points per game are the pivot point of this particular model. And so that's why you get this hourglass that gets sort of swept out, right? Now, maybe we're saying that those points are a little bit big and maybe they're not transparent enough, right? So let's maybe crank them down to a size 2 and then let's do 0.25, right? And so now when I hit enter, now you can see they're a little smaller, they're a little less dark, and maybe that's a little better for our plot, right? Now, I have my confidence interval for my means. So this is the confidence interval for the means, and it's related to the linear model because that's sort of the center of my data, right, in 2 dimensions is this line. What I want is the prediction interval. So the last thing that I'm going to do is I'm going to add the prediction intervals. Now, to do that, I'm actually going to use the predict function on my rushing model and do interval prediction, and I'm going to call it a new variable. I'm going to call it rushing prediction. Okay, and so I'm going to, again, copy this, and we're going to paste it in. Now, again, rushing predict is just the variable. Predict is a function that is going to predict the points per game from the rushing model, okay, because that's what the rushing model is doing. It's predicting the points per game from the rushing. And the interval I want is a prediction interval. Now, you can make the interval confidence, but we're going to cover that in another thing. Now, I got an error message there, so maybe I am concerned that rushing prediction didn't do what I wanted it to do, but it does. here is the predicted amount, and then the lower, and then the lower bound for the predicted points and the upper down bound for the predicted points. So now I have this nice data set rushing prediction. What I want to do is I actually want to add that predicted data to my football data, okay, so that I can put them all together. So what I'm going to do is I'm going to create a new data set, prediction data, and I'm going to bind together. I'm going to use the cbind function, right? So predict data. I got to change it to something else. I'm going to use cbind. This binds the two data sets together. The C for like the vectors, the columns. So I'm doing like a column bind function on with the football data combined with the rushing prediction data. Okay. So now I have one larger data set. So now when I look at predict data, what I get is not only the ranks in the team in the conference and the yards per game and the passing yards, right? I actually get the points per game. I get the model predicted points per game, the lower bound and the upper bound for it. Now you can see this is off by about 6 points. This is off by about 9 points. It's only off by about 3 points here. These are the residuals, right? The residuals are different for each one of these, okay? And so these are the predicted points for these are the predicted points per game that the model is suggesting. Okay, so that is working out perfectly. We're almost done. Hang in. Now the last thing that I want to do is I actually want to use my ggplot again, but now I'm going to add 2 lines to it. So I'm going to go in and I'm going to copy this. And again, like I did last time, instead of right typing it all in and having you watch me, I'm going to do the plot now, but I'm going to do it on predict data. Because remember, my predict data now has this lower and upper prediction values. I'm still going to set up my grid with rushing and points on the Y plus, now remember, I got to get rid of that, right? Points. So again, maybe my point size needs to be a little bit smaller. So let's make that 2 and let's make this a quarter. Okay. I'm going to smooth it out. There's my geo smooth with my linear model with my red and my fill for my pink for my confidence interval. And then what I want to do is I'm going to add a line. Here's the setup. The setup is lower, so the Y is going to be lower, okay? The color is going to be red, and I'm going to make it dashed so that you can tell the difference. So the main model is going to be red, and the lower prediction line is also going to be red, but it's going to be dashed. And then I need one more line for the upper prediction. So that's why I had to put these together, right? I got to put all these data sets together so that I have my rushing and my points and my lower and my upper all in one data set so that I can call everything. And again, I'm going to make that dashed as well. I'm double checking my code. I hit enter. And now you can see I have the upper prediction line and it's straight, right? It's parallel to my linear regression. And then I have my lower line. And all of the data is inside it, which it should be because this is my 95% prediction interval. I am predicting that 95% of all predictions, all data is going to fall within these 2 red lines, okay? And it has to do with the estimated standard error, and we're going to get into that another time. If this was helpful, if you understood the code, if you understood linear regressions better, if you've made a nicer model, then that's great, and that makes me happy.